Okay, so let's start the discussion, Bache. Okay, I need to share the screen again. Okay, so what we were discussing in the last class, it's regarding the free radicals, okay? And free radicals are like what I told you, that whenever an atom or a molecule has has odd number of electrons or an unpaired electron present in it, it is be considered as a free radical. You can simply see that when we will be discussing about the chlorines now. So chlorines usually found in what? Chlorines usually found in the molecular state, like the diatomic form. Okay, chlorines usually found in the diatomic form for us. Okay, so when we have the chlorines, we simply say that the chlorines are the ones which are formed in the diatomic form. And when we want to break their bond, as they are having the single covalent bond between them, it means that they both are sharing one electron with each other. When we just break this bond, they will be converting into the free radicals because they both will be having an odd number of electrons, means the 7 electrons and unpaired electrons between them. Okay, so this type of breakdown of the molecules is considered as the homolytic breakdown, okay, or the homolytic fission reaction. So you can simply say that in the homolytic fission reactions, we will be producing the free radicals. Is it clear? We have the two different types of the ions as well. The one is known as the electrophilic and the other one is known as the nucleophilic. Electrophilic are known as what? Electrophilic ions are basically the ones which will be the electron seeking ion. They are majorly the positively charged ions, okay? They are basically the positively charged ions, and they are the ones which will go for the ions or the sites of an atom where they will be gaining the electrons. Okay. Nucleophile is what? Nucleophile is basically the nucleus loving ion. It's always the negatively charged ion, which will be seeking the positively charged ion for attachment. Okay. Electrophile are the electron deficient ion, and nucleophiles are the electron rich ion. Is it clear, Vite?
Yes, sir.
Okay. Now let's see this. Now we need to move towards the IUPAC naming. What are the IUPAC naming? It's basically IUPAC means the International Union of Pure and Applied Chemistry. These are basically the rules. Regarding these rules, Alvina, I want you to just copy down fastly with me now because these are the important rules. Okay, don't take the screen. If you want, you can take the screenshot. But if you are easy for understanding, as just by listening the thing without writing it, it's good. But I recommend you to write these rules because these are the important ones, and I want you to understand every rule side by side. Got it? So the first point here is what? It's like these are basically the rules for alkanes. Okay. Alkanes are the basic ones, and alkanes are the ones for which I explain the rules very thoroughly. Then we'll be having the alkenes and alkynes and all other functional groups. Everyone has their little rule changes, but the basic rules are for the alkanes. Okay. So alkanes are the basic hydrocarbons. No? That's why. So at the very first point, whenever you are naming any hydrocarbon, you must select the longest chain. Okay, you must select the longest chain of the carbon atoms. Okay, these longest chain must be in a different way. Like they will be the straight line like this one. It will go like this way as well, this way as well, this way or this way. These are the different ways. Or the longest chain. But you have to consider this thing that the longest chain must be the longest one. Okay, it must be containing the most number of carbon atom, the maximum number of carbon atoms in a sequence. Okay, you're not allowed to go like this way. You're not allowed to go like this way. Got it? Got it? So the point here is what? It's like that you have to consider the longest chain first. And when you're done with the longest chain, you will be moving for highlighting the side chains. What is the side chain? Actually, the thing which is outside of the longest chain, you are seeing that this particular area is basically what? This particular area, let me write it first again. Okay, so this particular area is basically the longest chain which is inside this box. I always recommend the students to draw the box on the longest chain so you can easily identify. This is the longest chain. All the things outside of this box, all the things apart from this longest chain are considered as a side chain. So you are considering the side chain here as the CH3. Got my point?
Yes, sir.
So at very first start giving the carbon atoms numbers, start from that side where the side chain is near. As we are discussing about the alkenes here, so there is no functional group, there is no spatial property, there is no speciality in the group, but the only spatial thing or the different thing here is the side chain. Okay, so you need to consider that thing. You got my point?
Yes, sir.
Okay. Now let's see this. When you will be having this thing, so start giving the numbers from which side, from that side where you are observing that the longest sorry, the side chain is near. So you see that these are the two sides. One, maybe you can start from here or you can start from here, but the point is that we will be starting from the right side. The phenomena is that the side chain is near to this side. How it is near? It will this the carbon on which the side chain is attached, it is having the number 2. Okay, the second carbon, and from the left side it is having the fourth number in the chain. So that's why this side is near, that's why we will be considering this side as the starting side. Okay, as these are the open chain compounds, so one side is the start and the other side will be the end of it. You got my point?
So right is always the starting.
No, right is not always the starting. You have to see that from which side the side chain is near, so you'll be going on that way. You got my point?
Yes, sir.
Okay, note down these points. Now we will be having some cases in this third point, okay? Okay, now let's see that what cases we have here. The cases will be like what? Maybe there's a possibility that we will be having the two different side chains. So what you'll be preferring? You see that from the right side, the first side chain is basically on the third carbon. And from the left side, the first side chain is on basically the second carbon. So which side will be preferred? Left side or the right side?
The left side.
Exactly. So you will be preferring if more than one same side chains are there, select that side from starting of count from where we will be having small number of the side chains. So we will be starting from this side. Okay. All the two other things like the two attachments, the 2 and 3, these are basically the side chains. If we have different side chains, we move from more than one. Different side chains, more than one, and they both are on the different numbers of from the different side. You see that if I start from the left side, the first side chain is on the third number. And if I start from the right side, the first side chain is on the fourth number. I'm not just doing any kind of biasness during the between these side chains that which one is the larger one and which one is the smaller one, because I just came to know that from the left side I just got the side chain on third number, and from the right side I just got the side chain on the fourth number. So I will be preferring the counting from that side where I'll be having the small number for side chain. Is it clear? But this is the
Yeah.
condition when both of the side chains are on the different numbers from the different sides. If we get the different side chains, more than one, on the same positions from both of the sides, prefer the short side chain. You see from the left side, the side chain is on third number. From the right side, the side chain is on the third number. So from both of the side, the side chain preference is diminished. Okay, it's cancel out. So now we see the side chain, that what side chain it is. Or from the right side, we are observing the short side chain. Okay, on the third number. From the left side chain, we are observing the large side chain. So we will be preferring the short side chain. That's why we will be starting from this side. You got my point?
Yes, sir.
That's good. Now let's move. Now when we will be naming the hydrocarbons, so you have to do what? name the side chain first. At very first, you have to name the side chain. That what the side chain is, what is the name of the side chain. You will be identifying the side chain by simply the number of carbon, by just simply observing the number of carbon atoms present in the side chain. That whether it contains the 2 or 3 or 4 or what, how many carbon atoms it is contained. Okay, did you get my point?
Yes, sir.
If multiple side chains are there, put every number of the carbon atom on which that side chain is attached with comma in between them. Okay.
Yes, sir.
Then count the number of side chain. Then count the number of side chain. Then name of the side chain. Okay. If multiple different side chains are there, name them in alphabetical order. After side chains, name the longest chain name, like the count of the carbon atoms which are present in the longest chain, then AN. Got it? So these are the two countings which you need to remember. You done with these points? The last 4 point and its three cases, or you can say the steps. These are the important one for us.
Okay, sir. I'll screenshot them. Sir, can you go up? I'm done, sir.
Okay. Now let's see that what we have here. We have the two counts. The count for the longest chain and count for the side chain. Longest chain means that the main chain which we will be considering in at the very first point, we'll be just putting it into the box. Now that's the longest chain basically. The number of carbon atoms in the longest chain are considered as what? Meth, eth, prop, bute, pent, hags, hapt, oct, non, or dec. This is the counting for 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 for the longest chain, which is basically the alkane. Number of carbon atoms present in the longest chain. These are the number of carbon atoms. And it is also for the side chain. Actually, the name of the side chain, okay? Name of the side chain. The name of the longest chain will be considering these counting, and the name of the side chain will also be considering this one. And the quantity of the side chain. The quantity of the side chain will be mentioned by these countings. On your right side, mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. So is there any difference? Yes, start 5 are somehow the different. Okay, start 4 basically. Apart from all these 4, what we have here? We have a position. We have a position for the name of the sidechain, and the name of the sidechain can be mentioned by what? Can be mentioned by the counting of the largest carbons. Okay, just note down this countings. You done with this counting? So which way we'll move?
Yes, sir.
Now let's say here's the structure. If someone say, sir, I will be just considering the longest chain as this one. यहाँ पे एक side chain आ जाएगी and here is another. You can do that. Your answer will be same as mine. Okay. But you have to mention the longest chain. Like you see that in this sequence which I just selected as is the 5 carbon atoms. If you're having the 5 carbon atoms in any other direction, so you can go for that. Okay. So in this way, what I'll be doing, as per the points, I know that at very first I need to mention the side chains. It's like they both are same. Okay. They both are same, but they are present on the different numbers. So I will be writing the 2, 3. How many there are? There are 2. So 2, 3, die. And what is the side chain's name? I told you that the side chain names are also like this one. Method from. Okay. 2,4-dimethyl. 2,4-dimethyl. We're done with the side chains now. Now we need to go for the longest chain. It's like how many carbons? 5 carbons means pent. What type of bond between the carbon atoms? So it will be like a
Sir, why would we add di for the side chain?
di is basically the counting for the side chain. Now, how many side chains we have here? The same two side chains, na? So I will be mentioning their name with each other. Di is telling me the two. Actually, it's like an address. Okay, it's like an address. When you
Yes.
order something online and they'll be asking you the address, so you will be very much precise regarding your house, na? That this floor, this building, this apartment, this and everything, na? So this is basically the address of this molecule. Okay,
Okay, sir.
got it? Now answer this one. Do let me know when you're done with this name.
Okay, sir. Sir,
Yes, bete.
how do you figure out the middle name for this whole thing? Like for the first one, you wrote dimethyl. How did you know it was methyl?
Because it has only one carbon. One carbon means meth. One carbon means meth. Okay. And I know that the side chains are known as the alkyl. Okay. Okay. I know the side chains are known as methyl. Are you done with the name? So I'll let you know the name. So you can check yours.
I can't figure out the name. That's the only problem.
Okay. Let me tell you that how you can figure out the name. See this. At very first, you need to consider the longest chain. So this is basically the longest chain for us. How many carbon atoms are there in the longest chain?
6.
I'm, I'm asking you, Vijay, that these are basically the hydrocarbons. This is basically the hydrocarbon, which is basically important for us. This is the longest chain. I'm audible clearly?
Yes.
Okay. Now, apart from this, everything will be like what? This is a side chain, this is a side chain, and this is the side chain. Got it? Now I need to mention that which side chain is what. It has one carbon, it will be methyl. It has two carbons, it is ethyl. It has one carbon, it is methyl. From which side I will be starting the counting first? Left side or right side?
Left.
Tell me. Okay. So from this side, as we have the यहाँ तक बात clear होती है? Is it clear, बेटे?
Yes, sir.
Okay. It's like the 5 for us, and this will be the 6 for us. Okay. Now let's start the discussion. At very first, you need to name the side chains. Okay. So what's the name of the side chain? We have the two methyls and one ethyl. I told you that whenever you have the different side chains attached in a compound, you have to name them in an alphabetical order. So in alphabetical order, M comes first or E comes first.
E.
So how do you know that it is M or it is E? I told you that if you have one, it is methyl. If you have two, it is ethyl. If you have three, it is propyl. Okay. So this is E. So I will be writing the name as the 3. It means that I'm done with this. Okay. Then I have on the second and the fourth carbon. Okay. 3 ethyl on the second and on the fourth, as we have the 2. It means the 2 means the di. Got it?
Yes, sir.
3 ethyl, 2 4 di, methyl, and what we have here? What is the methyl? So it's like the 3 ethyl 2 4 dimethyl. We are done with these all side chains. Then I need to give the longest chain name. How many carbons are there in the longest chain?
6.
Okay, 6 means that it will be the hex. And what type of bond between the carbon atoms in this chain? Single. It's like 3 ethyl 2 4 dimethyl hex. Done with this? Now name this structure, which is.
Yes, sir.
Done with the name?
Just 1 second.
Now let's name them. Tell me your name was you did.
Sir, I'm still not done.
Okay, I'm just giving the 2 more minutes for it, okay? Try your best to do that.
Okay, sir, I'm done.
Okay, Arvina, tell me the name, Bache.
I wrote 4,5-ethyl and then 3-tetramethylheptane.
अच्छा देखिए दोनों में साइड चेन्स कहाँ हैं हमारे पास दोनों में साइड चेन्स बहुत सारी हैं just tell me your answer what was that 2,5 diethyl
4,5-ethyl and then I wrote
no
3-tetramethyl.
it'll be like what 4 5 diethyl why I'm just putting the di here this di is telling me that these are basically the two if you wrote the 4 5 ethyl it'll be it is possible that your answer will be correct okay so you have to mention the di
Okay. And then for the
4
next, yes,
for the next one what
I wrote 3-tetramethylheptane.
the thing is that
Oh wait, I think
diethyl
I named it wrong.
4 5 diethyl then it will be the 3 methyl okay 4 5 diethyl then it will be the 3 methyl okay so now at this point we are done with these side chains okay got it as we are done with these side chains then we'll be moving for the longest chain how many carbon atoms are there in the longest chain it's 7 it's what it's 7 so 7 means what hapt exactly that's good haptane got it 4 5 diethyl 3 methyl haptane that's done now let's move towards the formula or the rules for the alkenes. As you see that the alkenes are basically the unsaturated hydrocarbons, they must be having the carbon-carbon double bonds. Okay, alkenes are the ones which will be considered as the unsaturated hydrocarbons, and they will be having the carbon-carbon double bond. Did you get it?
Yes, sir.
Okay, that's good. Now let's see that the longest chain. What's the first motto? We need to consider the longest chain, and the motto for considering the longest chain is what? That it always be having the carbon-carbon double bond. Maybe there's a possibility that in some way you'll be having more carbon atoms, but you're not allowed to leave the double bond outside as a side chain, okay? Because we will never be giving the name to the side chain which contains the double bond, okay? Double bonds are never mentioned in the side chain. You got my point?
Yes, sir.
That's good. Let's see this. See, that name will be like what? The side chain, then the longest chain carbon atoms, then the number of carbon atoms from which the carbon-carbon double bond starts, that the count of the carbon-carbon double atoms, then E. This is the one. You see the structure, the first structure here, it has the two methyls attached, and what will be the name of it? It's like the 3,3 dimethyl. How many carbons in the longest chain? 5 means pent. The number of carbon atom from which the double bond is starting. Okay, but you need to understand that what will be the preference now. We will be preferring the carbon-carbon double bond. Okay, we will be preferring the carbon-carbon double bond. So we will be starting the counting from this side: 1, 2, 3, then 4, then 5. Got it?
Yes, sir.
Okay. So we'll be starting from that side, and we'll be having the double bonds. Uh, we just try our best to get the shortest number for the double bond now. Okay. So smallest number for the double bond here. It's like the 3,3 dimethyl pent 1 ene or 2 ene. From which carbon atom the bond is starting? Tell me, from which carbon atom the bond is starting? The carbon atom, we have the 5 carbon atoms, and the bond is starting from the first carbon. It is like simply ene. You can write the pent 1 ene, but we never show the 1. Okay, we never write the 1 here. Okay, so it will be like what? The pentene. It's like what? The pentene. Did you get it?
Sir, could you explain again?
Okay, so it's like that. The main points are like the same. It's like what? That we need to consider the longest chain. Okay, we are considering it, but the twist now here is what? That you have to consider the longest chain, and you have to see that in this longest chain, there must be the carbon atoms which are having the double bond present in it. Got it? So the carbon atoms which are having the double bonds, they must be present in that longest chain. You're not allowed to leave the carbon atoms of the double bonds outside of the longest chain. Got it?
Okay, sir.
Okay. So when we are done just selecting the longest chain, everything which is outside of the longest chain, it is considered as what? The side chain. Now we have the side chains as well as the longest chains. Okay. Now we'll be naming the molecule. Okay. We will be identifying the side chains first as like the methyl, ethyl, propyl. Okay. Always remember that the side chains are the alkyl. Okay. Methyl, ethyl, propyl, butyl. These are basically considered as the side chain for us. Okay. So we need to see that if the molecule is having the double bond, we need to prepare that side that from which we will be having the carbon-carbon double bond small number. Okay. We will be preparing that side for counting from where we will be having the carbon-carbon double bond smallest number. Got it?
Yes, sir.
Okay. Got my point? Now note down the name of the first structure and the structure of the second one. In the second one, what you are observing? If you go, let me show you that. If you go like this way, let me draw it for you. If you go like this way, you will be having how many carbons? The 7 carbons. Okay. But if you are going in this way now, which I just show on the right side here, if you go this way, you will not be able to consider the carbon-carbon double bond in the longest chain. And the main motto here is that to consider the carbon-carbon double bonds in the longest chain. That's why I consider the longest chain as the 7. Okay, that's why we consider the longest chain as 7. The point is that we have, sorry, the longest chain as the 6th one here. The point is that we have 7 carbon atoms in the other way, in the other direction, but we will not be considering that side. Why? because we will be considering that side where we are having the carbon-carbon double bond. The carbon-carbon double bond is mandatory and a very important thing for us. You got my point? So it's like
Yes, sir.
what? The 2-ethyl, 5-methyl hex from one carbon, the double bond starting, and from the third carbon, it's like the hex 1,3-diene. Hex means the number of the carbon atoms in the longest chain. 1,3 are the carbon atoms from which the double bond is starting. Di means the two carbon atoms, and ene means the alkene. Okay. Whenever you have a carbon-carbon double bond, you have to mention the ene at the end. Okay.
Okay, sir.
Did you get it? Okay, that's good. Now note down this one and name this one. Name the last one in your notebook.